For section 7.2, we can start by thinking about multiplying two-digit numbers using a generic rectangle. So the way this works, these quantities represent the side lengths of the rectangle, and then multiplying them would represent the areas. So we have 200, 30, 80, and 12. So then the total product or area would be all of these quantities added together. So 200 plus 30 plus 80 plus 12 would be a total of 322. So that's like saying the quantity of 10 plus 4 times the quantity of 20 plus 3 equals 322. Now, the process with multiplying polynomials is a little different because instead of just constant numbers, we have variables as well. So in this first example, we're multiplying a monomial by a polynomial. And remember, it's called a monomial because it's one term, and then this specific polynomial has 4 terms. So whenever you're multiplying by a monomial, you can just simply distribute that term to each of the terms of the second factor. So I wrote out what this would look like by distributing negative 3x squared to every term. And then once we actually multiply, then we're left with the product of negative 12x to the 5th plus 6x to the 4th minus 3x to the 3rd plus 30x to the 2nd power. Remember, in these cases where we're multiplying like bases, we add the exponents. So in our second example, we're multiplying 2 binomials. So each factor has 2 terms, and that's why we would use a 2 by 2 generic rectangle. So looking at this, we multiply 4x by 2x, which would be 8x squared. 2x times 2 is 4x. Negative 1 times 4x is negative 4x. And then negative 1 times 2 is negative 2. So our total product, or if we're thinking about the total area of this generic rectangle, would be 8x squared plus 4x minus 2. But then combining like terms, we're left with 8x squared minus 2. In the next example, we're multiplying a binomial by a trinomial. So now we have 2 terms multiplied by 3 terms. So factor 1 is a binomial, factor 2 is a trinomial. So notice we have a 2 by 3 generic rectangle. So multiplying each term, x times 3x squared is 3x cubed. X times negative 2x is negative 2x squared. X times 4 is 4x. Negative 5 times 3x squared is negative 15x squared. Negative 5 times negative 2x is positive 10x. And then negative 5 times 4 is negative 20. So adding all of those terms together, that would look, so I'm actually going to combine like terms as I'm adding. So notice these are like terms since they're both x squared, and then these are like terms since they are both just x. So I have 3x to the 3rd power minus 17x to the 2nd power plus 14x minus 20. And that is my total product. In the next example, this is actually called a perfect square since each of our factors are the same, and that's why we can write this as 2x minus 5 to the second power. Now, some people try to tell me that this is equivalent to 4x to the second plus 25. However, they are missing a crucial part, so this is not correct. So if we actually write this out as two factors of 2x minus 5 and use a generic rectangle, we see the 4x squared and the 25, but we also have to multiply 2x minus 5, or 2x times negative 5, twice. So that's negative 10x and negative 10x. So the original person over here was missing one of the terms of the product. So the total product would actually be 4x to the second power minus 20x plus 25. Now, there is another option of multiplying polynomials beyond just the generic rectangle, and this idea is multiple distribution. So what we're actually doing is distributing this 2x to both terms or each term in the second factor. That gives us 4x squared minus 10x. But then you're also distributing the second term in the first factor to each term in the second factor. So negative 5 times 2x is, again, negative 10x. And then negative 5 times negative 5 is positive 25. So notice the same process is occurring. You're still multiplying all of the same terms. It just looks a little bit different than what you see in the generic rectangle. But in the end, we still have the same final product of 4x squared minus 20x plus 25. And in this example, we're multiplying a binomial by another polynomial. We just call the second factor by a polynomial since it is 4 terms, and we don't have a specific name for that. So notice the generic rectangle itself is 2 by 4. So our product, 2x times x cubed, is 2x to the 4th. 2x times 2x squared is 4x to the 3rd. 2x times negative 2x is negative 4x squared. And then lastly, we have 8x in the top row. In the bottom row, we have negative 4x to the 3rd power, negative 8x to the 2nd power, positive 8x, and negative 16. Once again, we can see in this case that our like terms are diagonal from each other. Notice because they have the same variable and the same exponent. So adding those all up, my total product or area is 2x to the 4th power. The x cubes actually add to 0, and then minus 12x to the 2nd power plus 16x minus 16. So looking at the second page, I do want you to try these on your own. So go ahead and pause the video and attempt them before taking a look at the answers. In this first one, the final answer is 4x squared minus 16. Notice the like terms do cancel each other out. And in the second problem, notice we've got 3 terms in the first factor. All right, so that has to go up here where there are 3 spaces for each term. And then the second factor, g minus 8, would go here. Please don't forget that negative 8. It is important as part of your total factor. So once we've multiplied, we can recognize the like terms. So I've written all of the terms out first. Right here. But then when combining the like terms, our final product is 7g to the third power minus 52g to the second power minus 31g minus 8. As a reminder on your notes, it should say this, but we must remember to combine like terms, which like terms are only terms that have the same variable and the same exponent.